All right, we have the equation here. The question here it says show that the equation kx squared plus 2k plus 1 x plus k plus 1 equals 0 has real roots for all the values of k. So this is dealing with quadratic equations. All right. First of all, this is the format of a quadratic equation. Ax squared plus bx plus c equals 0. Now, in order you find if a quadratic equation has real roots or imaginary roots. Real roots, these are your typical numbers, the any negative numbers, positive numbers. Then imaginary roots, these are your imaginary numbers. Okay, mathematics is what we call the imaginary numbers. All right, so to find out if a quadratic equation has real or imaginary roots, the roots basically is just the values of x. When you hear roots, it's just what are your values of x. We need to bring in the discriminant. All right. And the discriminant, this is the formula for the discriminant, b squared minus 4ac. So if the discriminant is less than 0, you have imaginary roots. For example, like the square root of -4. If you go on your calculator and type in the square root of -4, to give you an imaginary. But if d is greater than 0, okay, you have real roots. And if d is less than 0, you have imaginary roots. So what we need to do is we need to find our discriminant. Madam Juliet, your mic, your mic. Yes, so from this quadratic equation, if our equation which has been given here, if we put it in the format of the quadratic equation, our a is going to equal to k, as you can see, kx squared, here ax squared. So we're going to say k, we're going to say a equals to k. All right. Then you have bx here. So b is going to equal to 2k plus 1. All right. As you can see, it's 2k plus 1x. So our b, then our c is k plus 1. All right. So these are what we're going to transfer into the formula for the discriminant here. Because one find if this quadratic equation has real roots, and the discriminant is what tells us if it does or if it doesn't have. So b squared will replace with the 2k plus 1 squared. minus, then we're going to say 4 a, we replace it with k, so we say 4 times k, 4 times k, and then c is k plus 1, so replace c with k plus 1. So 4 times k times k plus 1. So what we've done, we've just replaced b, a, and c with these values, which we derived from our original equation here. So first things first, let's expand this here. So you say 2k plus 1 times 2k plus 1 minus, you can say 4 times k, that is 4k, open brackets, k plus 1. So we expand. So I'm going to say 2k times 2k, that gives us 4k squared. Then 2k times 1, that gives us 2k. And we're going to say 1 times 2k, that gives us 2k. Then 1 times 1, that gives us 1. Then here we also expand here. We're going to say negative 4k times k. We get negative 4k squared. And then negative 4k times 1, we get negative 4k. So we simplify here, we have 4k squared, 2k plus 2k, that gives us 4k, plus 1 minus 4k squared minus 4k. So we arrange like terms together. So you say 4k squared minus 4k squared, that is 0. 4k minus 4k, that is 0. So our discriminant d equals 1. All right. And if your discriminant is greater than 0, then you have real roots. Yes, so it has real roots for the values of k.